Now, today we are considering a question from Cambridge International Examinations, that is Cambridge International Advanced Subsidiary and Advanced Level. So the paper that we are considering is paper 6, Probability and Statistics 1, known as S1. The code is 9709/61. The paper was taken October-November 2017. So the question of interest is question 1, which reads, the discrete random variable x has the following probability distribution. X takes the value 1 with the probability of 0.15. It takes the value 2 with probability of p, and it takes the value 3 with probability of 0.4. It takes the value 6 with probability of q. Now, given that expected value of x is equal to 3.05, find the values of p and q. That is 4 marks. Yeah, that's just it. So that is the question that we want to find the solution to. Well, we look at the question as shown, and as we have seen, we are given the probability. We are given the probability of this discrete random variable as we have x and probability that x takes that value. So x takes the value 1, it takes the value 2, it takes the value 3, and it takes the value 6. And we are told that it takes the value 1 with the probability of 0.15. It takes the value 2 with probability of p. It takes the value 3 with probability of 0.4. And then it takes the value 6 with probability of q. Given that expected value of x is 3.05, find the values of p and q. Now, expected value of x should be given by the summation we say expected value of x is given by the summation of x dot p of x is equal to x. That is what gives us the expected value. But again, we also know that the sum of the probabilities should also give us 1. So we can then use that fact to form an equation involving the probabilities whose sum should be 1. And that is like saying the only unknown are p and q. So I say p plus q. I say p plus q. Now my q is not looking good. P plus q plus 0.4 plus 0.15, that's 0.55, plus 0.55 should be 1 because total probability should be 1. Total probability sums up to 1. So if that is so, then this should imply that p plus q alone should be about 0.45. And that's my first equation. Now, my second equation should, we are told that the expected value, we are given the expected value, we are told that the expected value, that's the mean. So expected value of x, we have been given to be 3.05. This is a discrete random variable. A discrete random variable takes up whole numbers or integers. So we use this and equate to this. Then that will allow us to form the other equation. So the expected value of x, we could as well get expected value of x as 1 times 0.15, that is 1 dot, let me just say 1 times 0.15, let me just put a bracket, 0.15 plus 2 times p, which is 2p, plus 3 times 0.4, which is 1.2, plus 6p is equal to 3.05, this. So this is just 0.15 because it's 1 times that. So 0.15 plus 2p plus 1.2 plus 6p is equal to 3.05. So we can collect the like terms. 2p plus 6p is 8p plus 0.15 plus 1.2 is 1.35. That's 1.35 is equal to 3.05. It's equal to 3.05. So that should imply, no, this is Q, 6Q. This is 6Q. This is 6Q. Sorry. That is 6Q. Not P. It is 6Q. So this is Q. Now, if that is Q, that changes the argument. So it becomes 2P plus 6Q should be 3.05 minus this plus this. So I said that 0.15 plus 2 plus 1.2 is 1.35. That's what I said. So here we subtract 1.35. Therefore, 2P plus 6Q will be 3.05 minus 1.35. That is 0. This is 7. 1.70. So is equal to 1.7. So that's the second equation. So I have two equations. One is 2p plus 6q is 1.7. The other one is p plus q is 0.45. So let's solve simultaneously and see what we get. We solve simultaneously. So that means we have p plus q. P plus q is equal to 0.45. That's my first equation. My second equation is 2p plus 6q plus 6q is equals to 1.7. So that's the second equation. So I can say let p be 0.45 minus q, like that. Therefore, if I substitute it here in the second one, it can be 2 into 0.45 minus 8. No, minus q. This is q, not 8. Looks like 8. Minus q plus 6q is equal to 1.7. So opening the bracket, this gives me 0.9 minus 2q plus 6q is equal to 1.7. So collecting the like terms, if I take this the other end, 1.7 minus 0.9, that should give me 0.8. So I have, here I have 6Q minus 2Q. So 4Q is equal to 0.8, implying that Q is 0.8 divided by 4, which is 0.2. So Q is 0.2. If Q is 0.2, then I substitute this value of Q. I substitute the value of Q here to get the value of P. So if I brought it here, if I bring 0.2 here, so it will be 0.45 minus 0.2, which gives me Q to be 0.25. 0.2, 0.25, 0.25. Now, those are the values that we have, and that is the answer. So you needed to remember that this is a discrete random variable. There are two types of random variables. There's a discrete random variable and a continuous random variable. So this particular case is a discrete one. And all you needed to know is to remember that the formula for getting expected value, which is the mean or the average, is summation. You sum from x here to here. So I could say from x, say from 1 to 4. Yeah, that's what I could say. Of x dot p of that. So if you work it out, you get that. Up to there, see you in my next video.